chemical equilibrium. Chemical equilibrium that should be focused on equilibrium established between reactant and product. We generally know reactant that should be react with each other or dissociate into some product. Okay, as we know, product get more stability, so the reaction will be forward. But in some of reaction, there should be some equilibrium can be established. That's why same amount of product that should be produced from reactant, equally same amount of reactant that should be produced from product. Okay, so there should be forward reaction and backward reaction. Both are possible and both are permissible. Okay, but some factor can be influence on this equilibrium. Chemical equilibrium, there should be decomposition reaction. Decomposition reaction means what? That is a compound decomposed to produce some product. Okay, if heat used, we can say that is thermal decomposition. If HU, that is photon, is used, that is called photochemical decomposition. As for example, if we consider PCl5 that should produce PCl3 gas plus Cl2 gas. All are gaseous reaction. Okay, how we can establish? That is, if we consider PCl5, that is Cl and Cl, and that should be Cl and Cl, this. As we know from chemical bonding theory, that is, there should be axially bonded chlorine. The bond of axially bonded chlorine, they are loosely bounded. Okay, axial bonds are weaker. So, this Cl and this Cl easily to go. Okay, now it produces PCl3 and Cl2. Okay, axial chlorine platinum chlorine bond that should be weaker. That's why axially placed chlorine, they are combined to each other and produce Cl2, and by this way they remove. But PCl5 that should be still there, which are equatorially spaced. Okay. Now we consider displacement reaction. There should be displacement of one element to other. That is, as for example, Zn solid, H2SO4 that should be react, and it should be produce ultimately ZnSO4 and H2. Okay, how? That is H2SO4 that should be dissociated into a 2H plus SO4 2 minus, and this should be converted into Zn2 plus, and this Zn2 plus and this SO4 2 minus that should be combined to each other. Okay, and this H2H plus that should be produce H2. Okay, so what we get? That is, this Zn2 plus and this SO4 2 minus to produce ZnSO4 aqueous, and 2H plus produce H2 gas. As we know, for any reaction, if any type of gas removal take place, so the reaction will be more feasible. As for example, some pericyclic reaction we get SO2 sulfur dioxide or acetylene gas or ethylene gas that should be removed. So that means the reaction is more favorable to this direction where gaseous molecules that should be removed. There are also other reasons also. There are sometimes due to gas removal, there should be in forward direction entropy, overall entropy that should be increased. So as we know, del G equal to del H minus T del S means entropy when more positive value, so del G gives energy that is will be more negative value. So the reaction will be more spontaneous in terms of thermodynamics. Okay. Now we consider double displacement or metathesis reaction. Most popular term is metathesis reaction, less popular term is double displacement reaction, but both are same. Okay, two compounds react to form two new compounds. As for example, AgNO3 and NaCl, both are aqueous state, that should be produce AgCl solid and NaNO2 aqueous. Means what? That is AgNO3 is a defined compound. NaCl also a defined compound, but they produce and they react to each other to produce completely defined to other compounds. As for example, AgCl and sodium and NaNO3. Okay. Okay. There should be always remember reversible, irreversible. If we consider reversible, that is there should be in equilibrium goes both sides. As for example, if we consider reversible, there should be A and B. A is the reactant, B is the product. There should be a equilibrium that should be there. So goes both sides, A to B and also B to A. Both can be permissible. Okay. Okay. But when we consider irreversible, there should be go only forward direction. Only reactant to product formation only take place. Okay. Reversible, always there should be equilibrium. As we due to equilibrium they are only possible the both of direction. Otherwise both of direction reaction does not permissible. Okay. But irreversible process never equilibrium reached. As always forward, so always reacting to product formation can be there. So there is no chance of equilibrium establishment. Okay. Now we consider physical equilibrium and chemical equilibrium. Equilibrium that should be divided into two categories. That is should be physically, that should be shown. There must be no chemical change. Okay. Other is chemically change. There should be chemical reaction or chemically changes can be there. As per example, physical equilibrium, ice and water at equilibrium. There may be, if we consider in some ice, we add some water, there should be some equilibrium. Some water due to ice, due to freezing condition goes to ice condition, and ice condition due to get heat from water goes to water condition. So by this way, in between of two phases, that is one is liquid, other is solid phase. So in two phases equilibrium maintain. Okay. At equilibrium, rate of melting of ice equal to rate of freezing of water. That should be same. Okay. Now we consider chemical equilibrium. There should be rate of forward reaction equal to rate of backward reaction. RF equal to RB. Okay. If we consider their plot at y-axis reaction rate and at x-axis reaction coordinate, there must be RF, that is reaction progress, forward reaction, and that is backward reaction. There should be in that region equilibrium maintained. EF equal to EB. Reaction progress, the forward reaction, because reactant concentration decreases. Okay. Reactant concentration decreases and product formation increases. There should be this type of things are there. That should be this curve decreases, this curve increases. Okay. When reactant concentration decreases means what? That is much available reactants are not there. So due to this rate decreases. But when product formation begin to start, there when time goes and goes, more and more product formation can be take place. So the reaction can be goes backward. So on that case, first case, due to reactant concentration of reactant decreases, so forward reaction that should be decreases. After that, when product formation are enough, when product formation increases, rate of the backward reaction that should be increases. But at a some time, both of the reaction rate will be same. Okay. Now we consider homogeneous reaction equilibrium. Homogeneous means what? That is all are same physical state or same phase. All are liquid, all are gaseous, or all are solid, like that. As for example, 2SO2, that is sulfur dioxide, that should be O2 gas, that should be there must be equilibrium maintained to produce 2SO3 sulfur trioxide. All are in the gaseous phase. So they are termed as homogeneous. Okay. But heterogeneous, there should be defined, because that is opposite. There should be phases are dissimilar or defined. Means if one species is exist as gas, other species that should be exist as liquid or solid. Means their overall gases are not same. Okay. That is example 3Fe solid, 4H2 gas, and that should reproduce Fe3O4 ferrospheric oxide solid and 4H2 gas. Okay, due to we see that is three phases are there. One is gas, one is solid. Two phases are there. Okay, so that is must be termed as heterogeneous. Okay, now we consider law of mass action. If we consider small a capital A plus small b capital B and small c capital C plus small d capital, there should be equilibrium in between A, B and C, D. Okay, rate of forward direction means that the formation of C and D. That is depends upon, that is Kf, rate constant. Kf actually not come when proportionality is there. Okay, if equal to, then Kf and Kb are there. Okay, if we consider proportional symbol, there should be, we have to mention there is no rate constant, because rate constant are proportionality constant. Okay, when we termed as equal to, there should be we mention rate constant. Okay, so rate of forward reaction depends upon concentration of A to the power A, concentration of B to the power small b. Okay, rate of backward reaction, that is small a, small b, small c, small d, they are coefficient of bigger a, b, c, d. Bigger a, b, c, d are nothing but they are reactant and product. Okay, and if we termed as bracket, that is bracket A, that should be termed as their concentration. That is the concentration of A. Okay. So rate of forward reaction is proportional to concentration of A to the power small a, concentration of B to the power small b. And rate of backward reaction, that should be proportional to concentration of C to the power small c, concentration of D to the power small d. Kf and Kb are rate constant of forward and backward reaction respectively. So mass action, what tell about this? Mass action tell that is rate of forward reaction equal to rate of backward reaction. That should be same. So their value also same. So if we omit their proportionality, we get rate constant. By this we get Kf equal to concentration of A to the power small a, concentration of B to the power small c, small b equal to Kb, concentration of C to the power small c, concentration of D to the power small d. Okay. Now consider, if we give Kf by Kb ratio, then we get what? This. That is concentration of C to the power small c, concentration of D to the power D by concentration of A to the power small a, concentration of B to the power small b. That should be termed as Kc. Okay, that should be termed as Kc. Now partial pressure, if we consider only partial pressure, no concentration, we consider partial pressure. So there must be small a, capital A plus small b, capital B. Small a, small b are what? They are coefficient of reactants, capital A and capital B. Small c, capital C and small d, capital D. Okay. So small c, small d are nothing but they are also coefficient of products C and D in forward direction. Okay. So Kp is nothing but that is similar Kf by Kb. Okay, in terms of partial pressure. That should be actually Kf P C to the power C into P D to the power D equal to Kb P A to the power A and P B to the power B. Okay. By this way, we termed as Kf by Kb. That should be equal to Kp. Kf by Kb, that should be equal to Kp. And Kp equal to partial pressure of component C to the power C coefficient into partial pressure capital D to the power small d by the partial pressure of capital A to the power small a into partial pressure of capital B to small v. Okay. Okay. Kc less than 1 means product concentration lesser than reactant. Means Kc means what? That is must be Kf by Kc. And if Kc is less than 1, means Kf and by Kc, that should be less than 1. Means forward direction less than Kb. That should be B. Backward direction means what? That is product concentration lesser than reactant concentration. Okay. Okay. Now by this way we always term as Kp, that is in terms of partial pressure, overall equilibrium constant equal to Kc in terms of concentration. Okay, Kc is in terms of concentration and Kp in terms of partial pressure. So Kp equal to Kc, RT, R is the gas constant, RT to the power del Ng. Okay, Kp equal to Kc, RT to the power del Ng. Del Ng is what? That is moles of product minus moles of reactant. In gaseous only we consider for gaseous phases, which are given as solid or liquid. They are not mentioned in mathematical calculation of del Ng. Okay, del Ng equal to moles of product which are present as gaseous state minus moles of reactant which are present as gaseous state. Okay, so there must be no chance for solid or liquid phases species are interpreted in this relation. Okay. Okay, now we consider when del Ng equal to 0. So power that should be 0. That is RT to the power 0. Right? So means what? That is Kp equal to Kc. Okay. When del Ng equal to positive, Kp that should be greater than Kc. Kp that should be greater than Kc. And del Ng equal to negative, that means Kp less than Kc. Okay, that is Kp less than Kc. Unit of Kc mole liter inverse, that is actually in unit of concentration, and Kp is the atm to the power del Ng. As we know, that is RT equal to what? Pv. Right? By this way we can say atm. RT equal to Pv. Pv equal to nRT. So if for 1 mole of gas, Pv equal to RT. By this way you can say atm. We are not mentioned volume term to the power del Ng. Okay. K that should be greater equal 10 to the power cube shows completion of reaction. If we consider for reaction complete or not, by this terminology, that is the value of rate constant. If we observe the value of rate constant, we can determine or we can say the reaction goes completion or not. So K greater equal 10 to the power cube means so shows completion of reaction. K less equal 10 to the power minus 3 shows reaction does not proceed at all. Okay. Now equilibrium constant is independent of initial concentration of reactant and independent of pressure of catalyst. That means actually this is not there. Okay, reagent, that should be reagent. Okay, that is does not depend on reagent concentration, depend on reactant concentration. Due to this, that goes forward reaction. Okay, that goes backward reaction. Due to La Satellite principle, all are developed. So there should be reagent concentration. Does not depend on reagent concentration, which reagent that should be introduced or which catalyst that should be introduced. So does not depend on the presence of reagent or catalyst. Okay. Now we consider reaction quotient. Reaction how we derive, that is nothing but that is Kc. Actually the numerical value of Kc that should be equal to Qc when in equilibrium. Okay. Okay. Kc equal to the Kc, that should be actually we know that is Kc value is those. Okay. But always remember it terms at Qc when there should be equilibrium. Okay. That is concentration of C to the power small c, so D to the power small d, by concentration of A to the power small a, so B to the power small b. Okay. QC greater than KC when reaction goes backward direction. Means what? When backward direction reactant concentration, that should be low, less than 1. Denominator low means QC overall higher than KC. Okay. Okay. When goes forward, QC lesser than KC. Okay. That should be termed as KC. Okay. And QC equal to KC. Okay. Now we consider del G minus del G0 equal plus del G equal to del G0. That should be equal to, okay, del G equal to del G0 plus RT ln QC. Okay. And when we omit ln and put log, LOG log, then we use 2.303 into log. Okay. So by this way we can get del G equal to del G0. Del G is the Gibbs free energy. Del G0 is the Gibbs free energy at standard state. Okay. Plus 2.303 RT log of QC. QC is the reaction quotient. Okay. As we know, ln equal to 2.303 log. Okay. Okay. 2.303 log. So that should be put it, the value. Okay. At equilibrium, that is overall Gibbs free energy, not standard state. Standard state, that should be their value, but Gibbs free energy, that is normally 0. Okay. So on that case, QC equal to KC. So we can put in place of QC, KC. Okay. So we can use in terms of QC the KC. So we get overall 0 equal to del G0 plus 2.303 RT log KC. Del G0, that is standard Gibbs free energy, is not to be 0. That should be having value. But only del G, that should be having 0 at equilibrium. Okay. Okay. So by put it in this side, del G0, we get del G0 equal to minus 2.303 RT log of KC. Del G, when del G comes in this side, del G will be minus, and if we omit minus sign of del G0, so we get del G0 equal to minus 2.303 RT log of KC. If we use partial pressure or we relate KC equal to KP, we can say also this equation also, that is del G0 equal to minus 2.303 RT KP. Okay. Okay. Now we consider last Atelier principle, the last topic. If a systematic equilibrium is subjected to change in concentration or pressure or temperature, the equilibrium shift in the direction that tends to nullify the effect of the change. If a systematic equilibrium is subjected to change in concentration, pressure or temperature, the equilibrium shift in the direction that tends to nullify the effect of the change. Where the change can be there, maybe for concentration, maybe for pressure, maybe for temperature, there should be, due to last Atelier principle, the equilibrium always try to nullify or negligibly make these changes. Okay. Concentration, if reactant in any side reactant concentration increase, so equilibrium goes forward. If the reactant concentration decrease, so reaction always go backward. Okay. Like for example, if one teacher tells their lecture, all students are learn faster rate, so teacher goes forward. Okay. But when the students are slow learner or they understand in slow rate, so teacher have to say this topic again to for better understand. Okay, same things are there in equilibrium. When the reactant concentration that should be high, so there must be no problem, there must be reaction goes to back forward. But when reactant concentration are very low, so there have to be the equilibrium goes backward direction to nullify the low concentration and produce the moderate concentration of reactant. Okay, now we consider pressure. Similar, no effect of pressure having same number of moles if number of moles change. Actually pressure having no effect, there we term as moles. Okay, if number of moles change, the equilibrium shift in the direction having small number of moles when pressure is increased and vice versa. Okay, shift in the direction having small number, where the small number of moles is there, on that time pressure is increased. Okay, by this way, that is pressure and moles are interrelated. There is not direct effect. No effect of pressure having same number of moles. If both sides same number of moles are there, so there must be no effect at all for pressure. If number of moles change, the equilibrium shift in the direction having small number of moles. Where the small number of moles are there, they have to pressure increased. Okay, and vice versa also. That is opposite also there. Now we consider temperature, exothermic, endothermic. Exothermic means heat release. Heat will be released means exothermic. Endothermic, heat should be provided. Okay, as we know for our daily life, that is brilliant. Brilliant means who have the ability to solve many difficult problem easily, right? By this way we can say these students are brilliant, but some students are weak. They are not capable to do this, or do but slower rate, or do with difficulties. Okay, so like for example, the reaction goes also two types. One is exothermic, other is endothermic. Exothermic means when the reaction goes, the reaction give the product that should be more stabilized due to this, or maybe increase entropy due to this, or other reason heat will be released. Okay, for endothermic, heat will have to be provided. Okay, so exothermic heat release, so low temperature favors for what? As heat release, there are no need for again heat. Okay, so low temperature can be favorable to perform the reaction. So we have no extra energy to be provided. Okay, but endothermic, high temperature favors the formation of product because there should be heat have to be given. Okay, so high temperature that's to be needed. We cannot measure heat, so we increase the temperature. By this way, heat will be automatically more provided. Okay. Okay. Next one, addition of inert gas at constant pressure. Inert means the gases which are do not react or do not produce any product or any complex formation or compound formation. Okay, they are basically they are inert in nature. They are unreactive in nature. Okay. Addition of inert gas at constant pressure. At constant pressure, inert gas when added, volume increases. Obviously, there must be fixed amount of volume are there. When inert gases are added, their volume definitely increased. When in any bottle, fixed amount of water is there and we add some milk, obviously volume increases. Same analogy, equilibrium shift where increase in number of moles. Okay, equilibrium goes on that direction where number of moles increased. So by this way, volume nullify. Okay, addition of inert gas constant volume. If addition of inert gas at constant volume, volume is constant, that should be constant pressure. Okay, and that should be constant volume. If volume is not changed, there should be no change at all. If volume is not changed, if as for example in bottle there must be fixed amount of suppose 25 milliliter or something 1 liter water are there, there must be 1 drop milk are added, so there must be overall volume is not changed. So there, this is the same type of example, that is addition of inert gas constant volume, there should be no change at all. Okay.